Welcome back, scholars. My name is Mr. Hinkle. I am your instructor for this lecture, Origin of the Universe, and today we are getting into the topic of the Big Bang Theory. This explains where our universe came from. It's the birth of a universe. How did this universe get here? Where did it start from? Where will it end? How did we get here now? These are all big questions that people have been wondering for a long time, and our cosmology and astronomy has allowed us to begin to gain some insights into these topics. So the Big Bang Theory basically describes the birth, the evolution, the growth, and the fate of our universe. And it goes like this. At some point, the entire universe, everything in the universe, and it's big. We talked about how big it was in the universe introduced, but everything, this great, big, giant universe was confined to a singular point. It was super massive, super hot, super dense. And the age for this is about 13.8 billion years ago. I will explain how we came up with that number, not the math of it, that's out of the scope for this, but the concept. So 13.8 billion years ago, this singular point, supermassive, very dense, really hot, cracked into the existence. I think of it like crack, the Big Bang. It probably made that noise. It's probably still making that noise. I wonder sometimes if you could hear every single sound in the entire universe, if you could just like put your ear to the universe, what would it sound like? It'd probably be like a harmonious hum of every sound in the universe going at one time. And it started 13.8 billion years ago, and it's never stopped since. So this timeline, we can see there was rapid expansion. Everything was just pure energy right at the beginning, and then that energy started to differentiate into different types of nuclear forces, and those nuclear forces allowed the energy to condense into matter and into dark matter, and the beginnings of what we know in the universe now began to come into existence. A lot was happening in that first little bit. And then differentiation into stars, solar systems, galaxies, galactic clusters, superclusters, making its way to where we are now. So the Big Bang Theory really began with the discovery by Edwin Hubble in 1929 that the universe is expanding. And so the way he did this, well, light travels in waves. There's the electromagnetic spectrum, which basically is the wavelength of light as it travels. Visible light is a very certain wavelength of the electromagnetic spectrum. So light gives off electromagnetic waves, light waves, we'll call them, and they have a certain length. So when we are here on Earth, looking through a telescope, we can measure stars. We can look at stars. Star here, star here, star here. Well, based on the length, the wavelength of the light, let's say it's going like this, like this, like this. The short of it is this light wavelength turns into a distance. And if you measure these through time, this light wavelength changes and the distance gets greater. Now, the wavelength of light is the red wavelength, so this is called a red Doppler shift, meaning that the wavelength of the red light in the visible spectrum is shifting, indicating that the stars are getting further away. And we still measure this. And in fact, here's the example. It's like if you have raisin bread with dough before it rises, then you leave it out, right? It's got some sourdough going in there. It's very active, live food, delicious. As the bread rises, the raisins get far apart. So if you measured the raisins before the bread rises, the distance between the raisins would be shorter. And this is what we see in the universe when we point these high-powered telescopes up at the sky. And so the basis for the Big Bang Theory is that we've got Earth and these stars that we're measuring all around in all these directions, right? Measuring the wavelengths, measuring the wavelengths, measuring the wavelengths, because Earth is in the center, not the center, but Earth is a member of the Milky Way galaxy, 200 billion stars, of the galactic cluster. It's big. We talked about this. If you take, and this is math that's beyond me, but I've listened to it and tried to understand it conceptually, this is where we're at. But if you take the rates of the distances for the expanding universe and you back calculate them, everything comes in together on itself about 13.8 billion years ago. So everything in the galaxy that is expanding right now, if we use those rates of expansion and then we reverse them, we can deduce one single point, 13.8 billion years ago. There's also, when you look out into the universe, cosmic microwave background radiation. These are faint traces of energy that's everywhere in the universe that is believed to be another indicator of this singular event at the beginning of the universe. The Big Bang Theory is our idea for how the universe started and how it is continuing to grow, expanding in every direction. So we know a lot of this because of telescopes. The Hubble telescope was named after Edwin Hubble, who discovered the expanding universe, was the premier space telescope until about 2022 when the James Webb telescope was launched and put into orbit, and now it is collecting data, measuring the light that is being transmitted from distant stars. And we can take these images and these measurements of this light to further refine our models and our understanding of how big the universe is, how big is expanding, and maybe we can get to an idea of what the ultimate fate is going to be of our universe. The Big Bang Theory explains where our universe came from, how it continues to grow, and what we observe as stars have shifting wavelengths relative to the Earth that is indicative of an expanding universe. Thank you so much. This is Origin of the Universe, the Big Bang Theory. We will see you in the next one.